chemical changes right here. You see where we are, right? Right here? Okay? In a physical change, the original substance still exists and has only changed in form. In a chemical change, a new substance is produced. Energy changes always accompany chemical changes. All right, classify as physical or chemical. Number 1, sodium hydroxide dissolves in water. That makes me think, I've got to tell you two things. These are two things that are always physical changes. Dissolving or solubility. And yeah, changes in states of matter. And changes in states of matter just mean solid, liquid, gas, any kind of change like condensation, freezing, melting is going to be a physical change. All right? These are two physical changes that that people tend to get mixed up and sometimes want to call them chemical changes, but they are not. All right, so number 1, tell me if this is a physical or chemical change. Sodium hydroxide dissolves in water. Physical. And you know what I'm going to do here? I'm going to highlight or circle the key word that kind of helps me decide if it's physical or chemical. All right, dissolve is the key word. Number 2, hydrogen chloride reacts with potassium hydroxide to produce a salt, water, and heat. Yeah, so that's definitely chemical. Very good. Number 3, pellet of sodium is sliced into. We're slicing something in half. That's definitely physical. All right, number 4, water is heated and changed to steam. Water to steam. Water to steam. Noah, physical. Very good. That is a state of matter change. Number 5, potassium chlorate decomposes to produce potassium chloride and oxygen gas. We're making a gas, so that's a chemical change. Okie doke. Iron rusts. That's chemical, right, Isaiah? All right. Rusts. What rusts? Color change, right on? All right. Number 7, when placed in water, a sodium pellet catches on fire. My goodness, that sounds pretty chemical to me. Hydrogen gas is liberated, that means released, and sodium hydroxide forms. What do you call that? Chemical. Anytime you have fire, you got a chemical change. Number 8, evaporation. Physical. That is liquid going to gas. That is a state change. Ice melting. Physical. Milk sours. Chemical. Sugar dissolves. Physical. Wood rotting. When wood rots, it turns really dark black and probably smells bad. Okay, chemical. 13, cooking, cooking, cooking. Anytime you cook, now, not just making a sandwich, but if you cook something, you're usually changing the chemical composition. In fact, chefs have to take chemistry classes. And in fact, at the University of Georgia, they have a whole class on the chemistry of chocolate. I know. Wouldn't that be nice? Yeah. Number 14, grass growing in a lawn. This is tricky. I'm going to explain it to you. How does the grass grow? Is it just being stretched? Water, sunshine. That's chemical, if I've ever seen chemical, right? When you grow taller, physical or chemical? Chemical, okay. A tire is inflated with air. Yeah, we're just moving air from one spot to the other, so that's a physical change. Food is digested. That's definitely chemical. I told this to my other class. They didn't like it. It was kind of gross. You want me to tell you this part? Yes. When you throw up, does that food look the same? No, because it started being digested, didn't it? And then it changed its mind. Yeah, but let it sit around for 15 minutes in your stomach. Yeah, we're done talking about it. Water is absorbed by a paper towel. What do you have when you combine a paper towel and water? Physical. A wet paper towel. That's a physical change, right? Okay, this is easy. Does this ring a bell from 5th grade? Yes. Hey, but it makes sense. Oh, what happens when you cook an egg? chemical, don't you have a new solid forming? Because that yolk was originally liquid, now it becomes solid. All right, physical chemical property. This is actually a little bit weird. Physical property is observed with the senses and can be determined without destroying the object. For example, color, shape, mass, length, and odor are all physical properties. If I tell you this pencil is blue, do I have to change the chemical composition of the pencil? No. Didn't I observe that with my senses? Yes. So that's a physical property. Now, if this pencil changes colors, then that's a chemical change that we're talking about, right? Okay. Now, a chemical property indicates how a substance reacts with something else. The original substance is fundamentally changed in observing the chemical property. For example, the ability of iron to rust is a chemical property. How do we decide if this paper clip is going to rust? Let's say it does rust. In order to observe it rusting, didn't it have to undergo a chemical change? Yes. Yes. All right. How do I decide if this toothpick is flammable? I got to set it on fire. So to observe that, is that going to be a chemical or physical change? Chemical change. So it's a chemical property to say it's flammable. All right. So let's go down here. To tell the density of something, right, this chalk right here, all right, this chalk, which is in here, it's dissolving a little bit. Y'all see that pink solid settling to the bottom? Okay. How can I make this dissolve more quickly? I could make it hot, I could shake it, I could, you know, jab my pen in there and crush it up, okay? Stir it, all those things. To take the density of that chalk, did I have to do a chemical change or reaction to it? No, I just put it in water and I can take it out of the water. As long as it doesn't dissolve, it's not going to change, and dissolving is actually a physical change. What? This is the chalk. Remember we put chalk in water yesterday? Yeah, can you see it? It's still in there.
From yesterday, you left in there? Hasn't dissolved?
Well, Andrew, it started dissolving. Oh, well, actually, if you see it sitting on the bottom, it's not dissolved. But it is slowly dissolving, because it does dissolve. Okay. What? It's water. Okay, to take the density of something, I have to measure its mass, and I have to measure its volume. To measure the mass and volume of this penny, I don't have to do any chemical changes to it. So that's going to be a physical property. All right? Put ketchup on it? Makes it yummy? Oh, okay. Well, it does do something weird. The acid in the ketchup will react with the penny. Would that be a physical or chemical change? Chemical. If it's doing something weird, it's probably a chemical change, right? What does it do? Come down here. Metals will usually not react with water, react with, right here. If I put the ketchup on the penny, it will react with the acid. The ketchup has acid in it to form hydrogen gas. That's what it would do. It would bubble and form a gas, and then this would form a new, the copper would form a new compound.
So, like, how about if you put ketchup on?
What's that?
So, if you put ketchup on the
penny. We'll have to see if she did anything else to it. We could try it. Can you get a ketchup from the cafeteria? Okay. All right. So down to this one, is that a physical or chemical property? If we observe that, have to observe that's a chemical property. What about flammability? Physical or chemical? Chemical. Solubility, dissolving. Physical. Supports combustion. That means fire again. Chemical. Good. If you taste something that's sour, you're observing it with your senses. Physical. Melting point. Physical, because we're talking about changing the state of matter, and that's just a physical change. Reacts with water to form gas. Keyword reacts, keyword reacts. When you see reacts, you want to say chemical, right? Hardness. You did this in earth science. When you test a metal, to test the, I think there's a Mohs scale of hardness, all right? And I can test all of these. What's the softest one of these three items? The toothpick is pretty soft. Is that a physical or chemical property to test and see how soft or hard they are. It's a physical change. Boiling point. Physical. Can neutralize a base. That's a reaction. That's a chemical change. Luster. Which has more luster, Mr. Penny or Mr. Toothpick? Shininess. Penny. That's a physical. We all observed that, correct? With our eyes. Odor. What does that penny smell like? Do I have to do a chemical change or use my senses? There we go. I'll be done teaching after this for the rest of class. They can do the quiz. We'll see. Okay. Pure substance is either an element or a compound, right guys? Right. Mixture, homogeneous or heterogeneous? All right. If I can point to a substance on the periodic table, one of these guys, for example, chlorine, all right, that is simply an element, right, Andrew Mason? Okay, so let's look at chlorine. We're going to classify that as a pure substance, but we're going to call it not just, we're going to classify it even more specifically and say it is an element, okay? Now, chlorine actually has a chemical symbol, Cl2. Even though there's two of them, there's only one of these boxes from the periodic table that represents chlorine, correct? Brandon, what's the chemical formula for water? H2O, okay. So if we have H2O, how many of these guys do we have? Hydrogen, oxygen, we have two of them. So if we have more than one element, we wouldn't have to classify it as a compound. It's still a pure substance, but it is a compound. Next, soil. Is the soil from your backyard exactly the same as the soil from my backyard? Probably not exactly the same, and in fact, different places in your yard are going to have different types of soil, probably. Different, combinations of soil. Pure substance or mixture? Mixture. Homogeneous or heterogeneous? Heterogeneous. Can't you look at soil and you see particles that are different colors sometimes? Sometimes you see darker black or even white or kind of shiny pieces in your soil. That's definitely a heterogeneous mixture. Sugar water. If you go home and make sugar water, it may be different from somebody else's sugar water, right? Different ratio. So that's going to be a mixture, but let's assume that it's completely dissolved. Is that homogeneous or heterogeneous? Homogeneous if it's all dissolved, okay? Oxygen. Oxygen has a symbol, O2. Pure substance or mixture? Pure substance, element or compound? Element. All right. Carbon dioxide, CO2. What is that? Yeah. What type? Compound. Because, Mackenzie, we have more than one, right? Right. More than one element. Rocky Road ice cream. That is super heterogeneous, isn't it? That's like pizza. That's a mixture of lots of stuff and it's chunky. Alcohol. This is right. Whoa. Hold on. This is acetone. Acetone and alcohol are similar in that they have chemical formulas. If it has a chemical formula, then what is it? It's either an element, well, it's a compound, okay? Either one. But the alcohol itself, if you could take it out, is pure, but then it's part of a mixture. A beverage that you're talking about is a mixture, but the alcohol component of it, if you separated it, would be a compound. All right? Pure air. Guess what's in pure air? Oxygen. Also some nitrogen. All right? And some carbon dioxide. Now, guess what? It's homogeneous, right? The air, you can get the same amount of oxygen no matter where you are in our room. So that's a homogeneous mixture. Iron is Mr. Effie. It is an element.
How do you sound for